Sweet. Okay. So, hello everybody. I'm Dean. I work for Near4, as Richard was saying. I work in the open source, group, and we get to do a lot of cool stuff, a lot of cool projects. But we also do a lot of support from customers. So the likes of Owen, for instance, using Seneca. We do some support on that. I want to talk to you about pattern matching. So what you've seen in Owen's presentation was pattern matching in action. And I wanted to give you an idea of some of the tools we have around that and why I think it's cool, essentially. Does everybody know what this is? Last line down the bottom specifically. So it's an object. Or is it? So Alan Kay is considered the father of object-oriented design or object-oriented programming. And Alan Kay is really upset because since the 70s we've been using software or using object-oriented principles incorrectly. So when asked about it, he had said he thought of objects as biological cells and or individual computers on a network only able to communicate with messages. And that looks more like this. So in this example we're using Seneca as well, but we've got a couple of others. Seneca is not the only one that does it. But if you can see in the ad, we are asking, or we're filtering for a particular pattern in messages, and all the messages come through in JSON objects. And in our act, we're sending out a message, which will end up over a Redis transport, which Seneca supports. As well as HTTP and TCP and a lot of other good stuff. But ultimately, this is probably more in line with what Alan Kay had said. So if you think about it, we've got a little object, which is our script in this case. It listens on the network via Redis, and it handles messages, in our case JSON objects. But don't focus on the objects themselves too much. So again, Mr. Kay said, I'm sorry that long ago I coined the term objects. This topic gets too many people to focus on the lesser idea. We need to focus on how we're communicating, not how we're building our individual objects. So Alan said, the big idea is, of course, messaging. And the key to making great and growable systems is much more to design its modules to communicate rather than the internal properties and behavior should be. And that's pretty much what Owen was showing you. When you start designing your systems more for how they're going to interact, it all just becomes a hell of a lot easier. So a guy that worked with us, Matteo Collina, he has a really, really good talk on this subject that goes into the object end a bit more. For now, we're just going to focus on the message on our object. But see, here's the problem. We use the word object, but we've ruined the word object at this stage. It's gone. Object now means class, var, my object equals new object. So let's call it a microservice. No, you were expecting this. You were expecting this. But we're not going to get into what microservices are. I'm sure you're all sick to death of caring about microservices. So we're just going to focus on the messaging. So our microservice accepts JSON objects. And this is an example of some of the messages that service we looked at earlier can accept. But the problem is, how do those messages get to the actual function, so the add functions themselves? How do the messages come in from Redis and end up in that particular function? And the answer is pattern matching. So there's tons of modules to do pattern matching. Richard has some, I've got some, Owen is now written plugins for some. So we've got Varo for the front end, which is a teeny tiny little version of, or a similar version of Seneca that just does pattern matching, no transport, no plugins, no nothing. We got Seneca, which is the big boy in the back end, so you've seen Owen do some really interesting stuff with that. We got Nanite, which is specifically for streams, so you can pattern match two streams together and then loop them in together and do all sorts of crazy stuff. We got Bloom Run tooling for fast pattern matching, so Bloom Run runs really, really fast and it uses Bloom filters. And we've got Patron, which is the engine that powers Seneca. Patron is super configurable. So if you need to do some really, really crazy stuff with your messages before they get into your, or before they get matched, or to ensure that a match is successful, Patron is probably a better option than Bloom Run. So So I've got some examples of each, just to give you an idea, and they all look very similar. So it's the same sort of functionality. It's just either for a different purpose or it's done a slightly different way. But ultimately, it's all JSON objects that are being pattern matched. So we built Varro because we're doing a Super SQL project on, and Richard's giving me the eye, so I won't reveal too much. We have a Super SQL project that's using React. And React is a super model. So the model is essentially that you take a piece of data, you write out your application, and when the state of the application changes, the whole thing cycles again. You keep very little state about the application. Your UIs become much easier to reckon about because at any given point in time, the only thing that's changing what it looks like is the data. There's no magic state in underneath. So the idea of Varro was that what if we could treat the front end like a microservice itself. So it works very similar to Seneca in that it's got a handle where you can listen to messages. It's got an act, so you can send messages out, and it's also got an observe. So that's every time you send out a message via act, you might want to do something about it. And this really matters on the front end because you might have, for instance, a menu that needs to open based on a particular message going out. And a lot of these things don't happen on the back end. They're more UI issues. So Varro handles that. But it doesn't do any transport. So you need to write your own transport for this. And the reason for that is because depending on the part of the application you're doing, you might have a situation where half of your application is communicating by HTTP because it's solid. Some of it's communicating over UDP because you need tiny little messages. And you could have streams in there as well for live data. So we don't handle any of that. We allow you to plug little small modules into Varro and handle that yourself. Seneca, of course, we got a huge look in there from Owen. But Seneca has got some really cool stuff. So it's got a level back storage. It's got a Redis transport. It's got TCP. It's got HTTP. It's got loads of Mongo. Actually, MS Access is there as well, believe it or not. It's buried somewhere in GitHub, but I swear to you, it is there. So again, the same principle. You add in you add in what you want to find, and you act on that as well. One of the interesting things is how the patterns are matched. Really depends on the engine you're using underneath. So in a lot of cases, how it works is match as many as possible, and if there's nothing else registered in the system, I'll take it if nobody else has it. But it does depend. So for instance, Bloom Run does a match first. So even if you have a more specific pattern, if it's registered later, it won't get matched. Whereas Pattern runs the opposite way. So how you do your pattern matching can change as well, because not all of those are equal. Nano is really cool. So I built this after talking to Richard about what pattern matching was, and we said, I want to do that with streams. So now we have pattern match streams, and you see in the example we've got drain and fill. These are just very simple reader and writer streams. You can pass in streams, pipe them all together, and do some really cool stuff with this. So I have a sample app on my GitHub called Industry UI, as far as I know. And it uses Nano. So all of the data gets streamed up, and all of the data gets streamed down, a little bit of React in there as well. We've also, on the tooling end, we've got Bloom Run. So Bloom Run is written by Matteo Colina, and Bloom Run was an itch that he wanted to scratch. So he loved Pattern, which was written by Richard and Power Seneca, but he didn't think it was fast enough. And Matteo does love things to go fast. Sometimes they don't work, but as long as they go fast, he's happy with it. So Matteo built Bloom Run around Bloom filters, and it does work super fast. But the problem with it is that it matches in a very specific way. So it matches based on insertion order. And that's what he had a need for insertion order matching. So originally he built a little add-in for Pattern, and then once he decided he was happy enough with it, he went ahead and built a much more specific module. Then we've got Pattern, so I probably need to bring that up just a little bit. So Pattern is really cool in that you can pass it in functionality that can be fire at different points. So it can either fire while you're trying to find things, it can fire while you're adding things into it, Patron and Blue Moon are both just the bottom level tooling. So they just give you the ability to either store a function or an object or a piece of data, and when you pass the pattern in, it'll either give you that back or it'll give you null. So it's Seneca and Bar and things like that to give you the functionality that Owen displayed. But if you want to, if you're thinking, you know what, I could do something really cool with this and integrate it into one of my own projects, you're probably more looking for Patron or Blue Moon. So you can use this stuff wherever you like. And we've got loads of samples available. So we've got a full microservice system. We've got a React starter sample. We've got a React with Flux starter sample that I just found out today. We've got a minimum viable product, which gets you running really quickly. And we've even got a workshop for Seneca itself. So the links for each of those are up here, and they'll be on the slides afterwards. So that's it. That's as quick as I can go. Go forward and pattern match. So if you need to get the slides, they're available online, or you can come tweet me afterwards and I'll send you on the link. That's myself. Thank you very much. Has anybody any questions? No? That's how it's good. So I either explain it really well or really poorly. I do hope you go ahead.
Yeah, is it, having had experience with all the different pattern matching libraries, do you have the same fundamental frustration that like the language does not lend itself well to pattern matching?
Yes,
absolutely. Do you have any ideas of how that can deal with it?
So one of the things I've done in Nanite, for instance, is, so you see here, it's really big because we have to pass in some sort of wrapper around the stream as well. So you end up getting to the stage where if I've got a reasonably big pattern plus the drain functionality, I end up having this huge horizontal mess. So one of the things we did with Nanite was we added in a dot pin. It doesn't do the same thing as what goes on in Seneca. All it does is allow you to specify the pattern, and it will give you back a function afterwards. So you can use that function later on. So you lose the command part in your wing, because now you just use that function on its own and it makes everything smaller. I still have to register that big old string. One of the other things is that the guy who's managing Seneca, Wyatt Burrell, has added in a piece of functionality for decoration, and he's taken this from Happy. So Wyatt's got experience with Happy. And what it allows you to do is to decorate the Seneca instance with your own functions. And it doesn't give you any special features, but what makes that really, really good is that you could preset up all your patterns as objects of the Seneca instance if you so wish, and just attach them that way. But in general, I find it's a small trade-off for. So what I found is I'm literally just putting the pattern on one end and dropping the function. That gives me a bit more readability while having long patterns, but I wouldn't train it for going back to the old way. I have experience with version of control and containers and things like that, and I certainly wouldn't go back to it. Anybody else? No? Awesome. I think I've beaten pizza. Super. Thank you again, everybody.